Welcome to another Charles tutorial video. In today's video, I'm going to show you how to make a sprite appear on the Commodore 64 or emulator. What? You don't know what a sprite is? Oh! Well, a sprite is a graphical character, and it can be moved like with a joystick or something independently from the other graphics on the board. Also, you can make if a sprite hits another sprite, you can have something happen. Well, first thing you got to do is you got to get a piece of paper and write grids all over it, or buy some graph paper, and then you're going to number it. Here, let me show you here. Now, sure, you can use your own graphic paper, and then you have to write numbers on it, or you can print out mine. I made a little chart here, and I put colors in it too to help you out. But if you take your paper and you label the rows 1 all the way down to 21, and on the top, well, that's a little different. We're going to start out with 128. Then we're going to have 64, 32, 16, 8, 4, 2, and 1. And then we're going to repeat that 2 more times. Right there, right there. Now let's start drawing our sprite. Draw whatever you want. Just kind of shade each one of these little things here.
After you're finished drawing your sprite, we're going to separate it into 3 parts. I'm going to start by drawing a line right after the 1 here, between the 128. I'm also going to draw it over here too. Now we're going to go to our first section of our sprite, and whatever boxes are shaded, we need to add up the number of the columns above. Since we have 2 boxes shaded in column 2 and column 1, we add those together and we come up with 3. We put that in our data list. Now let's go to the middle section of our sprite. We have 3 boxes shaded, so we need to add those 3 columns. 128 plus 64 plus 32 equals 224. We'll write that in our middle column on our data sheet. Now we go to our third section of our sprite, and there's no shaded areas, so we're going to write 0 on our chart. Now we're going to go to row 2 and do the same thing. There are 4 shaded areas on our sprite, so 8 plus 4 plus 2 plus 1, I say that's 15. Write that down. Now on to the middle, we have 5 shaded areas. 128 plus 64 plus 32 plus 16 plus 8 equals 248. There's no boxes shaded in the last section, so we write 0. And all we have to do is just repeat this, so let's speed it up a little bit.
How's that look? Pretty snazzy, huh? You can read it better now. So, all you have to do is take that data over there and put it into your program. Bring up my program. We haven't written it yet, but I'm giving you a sneak peek. From line 100 all the way to 300, that's where we put in our code. You just gotta punch it in there. That's the data for our sprite. But let's get to writing the program. So let's start with line 5 here.
Go ahead and fire up that old trusty old Commodore 64 here, because we're going to write some code. Our first code we're going to type in, we're going to start with line 5. So why did I choose to start with line 5 instead of line 4 or 3 or 2 or 1 or any other number? You see, your computer reads each line of code like a book from lowest to highest number. Sometimes when you're coding, you find out you forgot something. You forgot a line. It's a lot easier to add lines of code when you leave space. Anywho, let's move on here. We want to clear the screen, so we're going to type in print CHR $147. That will clear the screen. Hit enter, and it will save this line to the computer's memory. Jumping up to line 10 here, we're going to put a couple poke commands in here. Well, poke commands are used to change the colors of the screen. So, poke 5328 0,0 will change the border to black. And poke 5328 1,0 will change the background to black. Ooh, it's going to get dark in here. Oh yeah, and before I forget, see between the 2 poke commands, there's a colon there. Oh, what's a colon there for? Well, the colon is a separator that lets you put 2 or more commands in the same line. So instead of writing line 10, poke 5328 0,0, and then line 20, poke 5328 1,0, you can squeeze them onto one line. Put them both on line 10 as poke 5328 0,0, colon, poke 5328 1,0. Haha. Line 20, V equals 832. What could that mean? Well, Think of your Commodore 64's memory as a giant notebook with 65,536 pages because it has 64K of memory. Each page has a number on it. 0, 1, 2, 3, all the way up. Page 832 is a special page. It's where the picture for Sprite 0th goes. So when you write V equal to 832, you're basically saying, hey computer, remember that my Sprite drawing starts on page 832. Later, in line 30, you use that page number 832 to copy all the little dots, the Sprite data, into the right place. So the C64 knows what your Sprite should look like. If you didn't have line 20, it would be like trying to draw your picture, but not telling the computer which page of the notebook to draw on. It would just be lost. Line 30 is a for loop. This is like saying, hey computer, count from 0 up to 62, one number at a time. The variable I keeps track of which step you're on. Since a Sprite needs 63 numbers 0 through 62, this loop makes sure we handle all of them. The read, A, grabs the next number from the data lines 100, 110, 120. Think of the data lines like a grocery list. Read says, okay, give me the next item on the list.
Poke V plus I, comma A means.
Poke means take this number and write it into memory. V is 832, the starting address of the Sprite data. I is the loop counter, 0, 1, 2, up to 62. So the first time, it pokes A into 832. The second time, it pokes the next number into 833, then 834, 835, all the way up to 894. 832 plus 62. That fills up 63 memory slots in a row, which is exactly the size of one Sprite picture. What next means in BASIC, for and next always go together. For starts a loop telling the computer, repeat these instructions, counting with a variable like I until you reach a certain number. Next tells the computer, okay, go back to the for line, add 1 to the counter, and do it again, unless you've already reached the end. In plain English, in line 30, next means go back and do it again with the next number until you've done all 63. Line 30 is like saying, take each of the 63 numbers from my data list, one by one, and copy them into the notebook starting at page 832. That way my Sprite picture gets drawn into memory where the C64 can find it. Line 40, tell the VIC2 where the Sprite lives. This line points the VIC2 chip, the graphics chip, to where our Sprite data lives. 13 means our Sprite is stored at block 13 of Sprite memory. It's like giving the mailman your house number, so your Sprite doesn't end up in your neighbor's mailbox. Line 50, enable the Sprite, now we flip the switch. This poke tells the C64, yes, I actually want this Sprite to appear. Without this line, you did all the work for nothing, like making a pizza and then forgetting to turn on the oven. Line 60. This just sets up two variables. X equal to 148, Y equal to 90. By itself, it doesn't move the Sprite anywhere. It just remembers numbers in variables. Line 70 actually uses those variables to place the Sprite on the screen at X position 148 and Y position 90. Without line 70, the Sprite would stay at its default spot, top left corner. If you always want the Sprite at X position 148 and Y position 90, and you'll never change it. You could skip line 60 and just write 70, poke 53248, 148, poke 53249, 90, enter. Think of your screen like a giant piece of graph paper. X is how far across you go, left to right. Y is how far down you go, top to bottom. So every spot on the screen can be described with two numbers, X and Y, which is across and down. Why does your Sprite need them? A Sprite is like a little sticker you can place anywhere on the screen, but the computer has to know, where do I put it sideways? That's the X position. Where do I put it up and down? That's the Y position. If you don't tell it those numbers, the Sprite will just sit in the default spot, which is the top left corner, X equals 0, Y equals 0. Line 80. This sets the Sprite color. Poke 53287 is the VIC2 chip Sprite 0 color register. The number after the 9 tells the C64 what color to use. So this line changes the color of Sprite 0 to brown because 9 equals brown in the C64 color table. Think of it like grabbing a crayon out of a crayon box. Line 80 says, hey Sprite, color yourself with crayon number 9. Lines 100 to 300, Sprite data. This is where the Sprite actually lives.
Remember that piece of paper with that Sprite you made? And you had that data on the side. Oh, like up here. all you have to do is take that data and put it into the program starting with 100 and all the way down. And when you're done with it, just grab your trusty Commodore 64 at the end of your program to run it, type in RUN and return. Ooh. Yeah. I kind of like that sprite. It looks kind of like yours truly. Well, I hope you like my video. In the next video, maybe I'll show you how to animate it or make it move with your joystick or something.
And that's it! We just summoned a sprite onto the screen of the Commodore 64. You now officially know more about C64 graphics than 90% of Earth's population. Next time, we'll make this sprite move, because right now, it's about as exciting as watching paint dry. But hey, at least it's green paint! Don't forget to like, subscribe, and poke that notification bell before your sprite disappears.
See you later, Patrick Gator.